Hi everyone, today I'll be talking about my FYP project, Evolving Deep Fuzzy Ensemble Network, or EDFE, with its application in stock trading. Artificial neural networks are powerful tools for processing complex data due to their ability to learn from large amounts of data and make predictions based on these learned patterns. Artificial neural networks are computational models that are inspired by the biological structure and function of the human brain and have the capability to analyze complex unstructured data much faster than humans. However, with these benefits, they come at the cost of interpretability. These models are not transparent, or a black box. The rationale behind decision making is not known to users. This is a problem as it is difficult to fully trust a system when there's high stakes like billions of dollars in the case of finance, or people's lives in the case of healthcare. The problem domain for the project is the finance industry, or more specifically in automated stock trading using AI. As a typical trader, there are many trading strategies out there for anyone to earn a profit. But the stock market can be unforgiving as prices are not always predictable, even with various financial indicators being used. Without looking into the future, traders only have historical data to try and predict future price action. Furthermore, financial indicators that traders use are derived from these historical data, leading to these indicators typically lagging behind actual price movement. With all that in mind, the objective of this project is to create a predictive model that is interpretable and is able to make highly accurate predictions based on the unpredictable stock market to generate timely buy and sell signals to maximize profits. The proposed solution is the Evolving Deep Fuzzy Ensemble Network (EDFE). This model makes use of fuzzy logic to add interpretability to the overall system, and also uses an LSTM model for accurate decision making. To, to complement the benefits of both models, we use an ensemble network through a technique called stacking. The idea behind stacking is that there is a final meta model that takes in the outputs of the base models as input, which then makes the final prediction, taking into account the benefits of both base models. This is a simplified architecture of the proposed solution EDFE. In this ensemble network, the base models, the LSTM model and DENFIS, are running independently of each other. The model then passes through a meta model, which takes the base model's output as inputs before returning the final predicted value as a crisp output. The input data is originally the raw data retrieved online and is then fed to both base models. The fuzzy system, which adds interpretability to the network, takes in this raw data and returns an output. The fuzzy model also returns linguistic variables which humans can read to understand the reasoning behind the decision process. For the LSTM model, the inputs undergo a bit of feature engineering before being passed on to the meta model. The predictions made by the models are meant to look ahead into the future. In total, we look forward t plus 3 days, or 3 days into the future. However, the further forward we predict, the lower the accuracy. Hence, financial indicators are used to mitigate some of the inaccuracies in the model. The financial indicators used are EMA and MACD. EMA is the exponential moving average, and MACD is the moving average convergence divergence, which is a popular financial indicators among traders, but intrinsically both has lag. The predicted prices will be used to calculate more accurate EMA and MACD, which account for this lag. The trading strategies used are predicted MACD and the predicted EMA cross over with the original EMA. The latter is not a commonly used trading strategy, but shown good results in the backtesting. These are the results of the ensemble network on the various indexes used for comparison. The indexes used are the S&P 500 index, the SPY, the Nasdaq 100 index, the QQQ, and the Shenzhen index, SZI. As you can see, the accuracy of the one-day look-ahead of the various indexes are comparable and quite accurate. These are the various R2 scores, or the accuracies of the look-ahead days for the various indexes used. SZI had the lowest accuracy for the T plus 3, or the third day, while the QQQ had the highest accuracy. We will now take a look at how these indexes perform with the predicted prices through backtesting. With the predicted prices, we are able to derive a more accurate EMA and MACD calculation, which takes into account the lag. These profits were calculated using an initial 10k starting portfolio and only using 60% of the portfolio whenever we execute a trade. Initially, we assumed that the MACD would have had the highest profit, but after testing a few strategies, the predicted EMA crossing against the original EMA resulted in the highest profit. All three indexes have shown to profit, but only the QQQ and the SZI are shown. While the predicted prices of QQQ was the most accurate, its profit marginally inched out buy and hold. but this could be due to the QQQ having a meteoric exponential 4x rise since 10 years ago. The SXI had lowest accuracy and the lowest overall profit, but have had the highest profit ratio against buying and holding. Overall, the predicted EMA cross actual EMA performed the best across all trading strategies and for all indices, and managed to profit higher than buying and holding. Lastly, I'll talk about the limitations and potential future works. Firstly, the LSTM model is not functional online, while the DENFIS has the capability. Future work could include revising the LSTM structure to enable EDFE to be used on real-time data. Next, the model only does a 3-day look-ahead. This is primarily due to inaccuracies as observed previously. The SXI only had a 0.90 R2 score for T plus 3 or the third day. A possible future work could be to include more models for better accuracy. Having models for different market scenarios could be one way to do so. Lastly, the trading strategy now only focuses on EMA and MACD. Another possible future work could be to include multiple financial indicators to increase accuracy when giving trading signals. With that, I've come to the end of my FRP presentation. Thank you.